Welcome all learning minds. Let's start most important session in which we study or we derive relation between y, k, sigma and eta, which is elastic constant, and we can say it as Searle's relation. Okay, so let ABCD GHEFA means this is the cube. Okay, it's showing the cube. Here it is A, B, C, D, and G, H, E, F means here it is G, H, E, F. Okay, so this is our cube. It's a unit cube. Okay, so its length is unit, or every length is unit. Its volume is unit, its area is unit. Okay, and let a force Tx, Ty and Tz from tension we denote this as a T. Okay, Tx, Ty and tension Tz act perpendicular to the forces BE, HD and AF, GC, means in every direction or in every plane the force is perpendicular. Okay, like this, Tx, Ty, Tz in every direction. Okay, so this is the tension or force. Okay, so now let's get the idea why we take this cube. Okay, because what we have to do, we have to derive relation between the all elastic constant. Okay, so while applying tension or force in this AB direction, we got elongation. Okay, same we got compression. Okay, so we have Young modulus and Poisson's ratio. Okay, and then by applying Tz and Tx or any two direction, we have change in shape. So it's a shear strain. Here it's change in length. Okay, and applying tension in every direction. Okay, it leads to a change in volume, means bulk modulus B. Okay, so now we start. Let alpha be the increase per unit length, means increment or elongation is called alpha, or length per unit tension along the direction of forces, and beta be the contraction or compression produced per unit length per unit tension in direction perpendicular to the force. Okay, so we have alpha and beta. Due to elongation and contraction, the length of the edge become, so now this is very important because all the question is play around these three lengths. Okay, so length of AB, BE and BD. So first, what is the length of AB? Okay, so AB have first of all original length 1. Okay, because it's unit cube, plus Tx into alpha, means we apply elongation or increment or force which leads to increment is called alpha. So Tx is, so it becomes Tx alpha, and all other two direction is contraction or compression, so it's minus Ty beta and minus Tz beta. Okay, so we have AB. Let's see here. Okay, its idea is like this. Applying tension in this direction AB, it will lead to increment in Tx direction, and other direction Ty and Tz, okay, is decrement or compression or contraction. Similarly, now we can say that BE is equal to 1 plus Ty alpha. Okay, so it's B, so that means it's increment in Ty, and BD is increment Tz. Okay, and all other two direction is decrement, so minus Tx beta minus Tz beta. Okay, and similarly here BD minus Tx beta minus Ty beta. Okay, so it's our equation 1. Okay, so it's a very important equation. Now taking this, all the tension is equal to T, Tx, Ty, Tz is equal to T. Okay, all tension is equal. So what happens? Let's see. Tz alpha is equal to t. So it's t alpha 1, it becomes 1 plus t alpha. Let me read here, 1 plus t alpha minus t minus 2 beta. Okay, so minus 2 t beta. So when we take t common, it becomes 1 plus t alpha minus 2 beta. Okay. So now, case 1. Volume of the cube. So what is the volume of the cube? Length into breadth into height. Yes, here it is. Length cube or length into breadth into height. So, sorry. Length cube is equal to, we have length 1 plus t alpha minus 2 beta is our length. Okay, so 1 plus t alpha minus 2 beta cube. So 1 plus t alpha minus beta cube is a cube, means 1 cube, plus t cube alpha minus 2 beta cube means b cube, plus 3 a square b means 3 into 1 into t 2 alpha minus 2 beta, plus 3a beta b square means 3a is equal to 1 and b square is equal to t square alpha minus 2 beta square. So now neglecting square and products of alpha and beta which are very small. Okay, so here t cube, it's already t is a small. Okay, and square or cube is very small. Okay, so we can neglect this square. No, these two terms will neglect, 1 and 2. Okay, so now what we have? So volume of a cube 1 plus 3t alpha minus 2 beta. Okay, so here we have 1 plus 3t alpha minus 2 beta, and these two terms become neglected. So now increase in volume of cube. Okay, so it's a concept, final volume of cube minus original volume. We can say that like if we have increment in length, if it's a 5 semi and increment is 1 minute 2 semi. Okay, so now final volume is equal to, final length is equal to, in our case it's 7. Okay, minus original length is equal to 5, so change in length is 2. Okay, so in this way we can find the increment in volume of the cube, final volume minus original volume. So final volume is equal to 1 plus 3t alpha minus 2 beta, which we derive from here. So now you get the hierarchy. Why we derive the volume of the cube, and minus the original length, original volume is 1. Okay, it's because it's a unit cube, so 1 and 1 get cancelled out, so it becomes 3t alpha minus 2 beta. So bulk modulus is equal to stress upon volume strain. Okay, so now you can visualize, or now you can see the hierarchy of our question, that we want to find volume strain. To find volume strain, we want increment in volume, okay, or change in volume. Okay, and that's why we find volume. Okay, so this is the hierarchy, and to find the volume, or we find the length. Okay, and that's how we start. So now stress is equal to force upon area. Force is equal to T upon area is equal to 1 because it's unit cube. So volume strain is equal to 3T alpha minus 2 beta, which we already derived. So T get cancelled out. So it becomes 1 upon 3 alpha minus 2 beta. So it's our equation. K is equal to 1 upon 3 alpha into 1 minus 2 beta upon alpha. So we derive our first small and simple and sweet equation. Now the case 2. Okay, so now once again to find bulk modulus. So bulk modulus is related to volume, and that's why we start with volume. Okay, so that's why we start with volume. Now what is the case? Now we have to find Young modulus and the Poisson's ratio. So we start with Ty is equal to Tz is equal to 0. Why? Because we only want the length, okay, increment in length or decrement in length. So let's take Ty and Tz is equal to 0 and only focus on the Tx, okay. So as AB's length is equal to 1 plus Tx alpha. How? Because Ty and Tz is equal to 0. So let's take Ty and Tz is equal to 0. 1 minute. In the AB's length, Ty and Tz is equal to 0. So what becomes? AB is equal to 1 plus Tx alpha. Okay. Yes. So AB is equal to Tx alpha. And increase in length. So now you know how to find increment in length. Final length of minus original length. So 1 plus Tx alpha minus 1. Okay. So it becomes Tx alpha. Longitudinal or linear strain is equal to increase in length upon original length. Okay, so increase in length is Tx alpha upon original length is equal to 1. So our increment in our longitudinal strain is, or linear strain is Tx alpha, and Young modulus is equal to stress upon longitudinal strain. So stress is equal to force upon area, force is equal to Tx upon 1, area is equal to 1 unit, and longitudinal strain is Tx alpha. So now Tx get cancelled out and we have 1 upon alpha. So we get Young modulus, y is equal to 1 upon alpha. And once again you got the hierarchy, how we start or why we start. So what we have want? Longitudinal strain. To find longitudinal strain, what we want? Increment in length. Okay, and to find increment in length, what we want? We want the length, okay, or final length. Okay, and that's how we start our case 2, and we get the Young modulus y is equal to 1 upon alpha. So it's also the relation between two. Okay, relation between it's a relation between y and alpha. Alpha is the elongation. Okay, so length of HB is equal to 1 minus Tx beta. Why? Because Ty and Tz equal to 0. Ty and Tz is equal to 0. So length of B is equal to 1 minus Tx into beta. Okay, so here it is, length of the HB, and decrement in length B is equal to original length minus final length. Not this, it's original length minus final length. Okay, not final length minus original length, because we want to find decrement. So original length is 1 and minus final length is equal to 1 minus Tx into beta. So 1 and 1 get cancelled out and minus minus plus, so it becomes Tx beta. Lateral strain or a contraction is equal to Tx beta upon 1, or a decrement of length upon original length. So Tx of beta upon 1 is equal to Tx beta, and Poisson's ratio is lateral strain upon longitudinal strain. So lateral strain, we have lateral strain, yes, Tx alpha, and we have contraction or lateral strain and longitudinal strain. Okay, lateral strain is equal to Tx beta and longitudinal strain is equal to Tx alpha. Okay, so now put the value of these two equations. Sigma becomes Tx beta upon Tx alpha. So Tx cancels, so beta upon alpha. So sigma is equal to beta upon alpha. Okay, so putting value of equation 3 and 4 into 2. So equation 2 is, in case 1 we derive this equation, k is equal to 1 upon 3 alpha into 1 minus 2 beta upon alpha. So beta upon alpha is sigma from the equation 4. Beta upon alpha is sigma. So 1 minute. So it becomes 2 into sigma, okay, and 1 upon alpha is equal to Young modulus y, so it becomes k is equal to y upon 3, 3 into 1 minus 2 sigma, okay. Here I write why we do this step. So y is equal to 3k into 1 minus 2 sigma. So in case 3, we have to derive shear strain, okay. So we take Ty is equal to 0 and Tx plus Tz is equal to 0, or Tx is equal to minus Tz, okay, which means if you take two-dimensional case, we apply we apply force on this direction, means if it's a Tx, if it's Tx, and in this direction means it's Tz, okay. So it's both are in opposite direction, so it's Tx is equal to T minus Tz, okay, and by this it becomes shear strain, okay, or change in length. So now this becomes like this, okay. Now you get the idea what it becomes, okay, because we apply force in this direction and this direction. Let me write in this direction and this direction, okay. So it's a shear strain. So now AB is equal to 1 plus Tx alpha minus Tz beta. Why? Because Ty is equal to 0 and Tx is equal to minus Tz. So first write Ty is equal to 0, so it becomes 1 plus Tx alpha minus Tz beta, and now Tx, Tx is yes, Tz is equal to minus Tx, so it it becomes minus plus, so it's 1 plus Tx alpha plus beta. So longitudinal strain of AB is equal to Tx alpha plus beta upon 1, okay, means or is a change in length or a change in shape or change in theta or angular upon original length. So it becomes Tx alpha plus beta, and length of B is equal to 1 minus Tx alpha plus beta, okay. So from equation 1 you can find this easily from our equation 1, okay, in which we derive AB, B, and length of 3 edges. So 1 minus Tx alpha plus beta. Now contraction of B is equal to lateral strain, so it becomes, okay, 1 minute, this is elongation and this is the compression, as we derive in the Young modulus case. As change in AB is increment and change in BE is decrement, okay. So compression or contraction of B or lateral strain is equal to Tx alpha plus beta. So contraction is, okay, so contraction, so one important theorem is shear strain is equal to the summation of longitudinal and lateral strain at right angles to each other, okay. It's a theorem you can find in a reference book like properties of elements of properties in R.C. Brown and D.S. Mathur, okay. So longitudinal strain of AB and lateral strain B, okay. So what is a shear strain? Shear strain is equal to longitudinal plus lateral, so here we write the longitudinal AB plus lateral B, okay. So it becomes Tx alpha plus beta plus Tx alpha plus beta, so it becomes phi is equal to 2 Tx alpha plus beta. So now modulus of rigidity is equal to eta is equal to stress upon shear strain. Stress is equal to Tx upon 1 and shear strain is equal to 2 Tx alpha plus beta. So 1 minute, tx cancel out, so it becomes 1 upon 2 alpha plus beta. Taking alpha common, this becomes 2. This alpha is common, so it becomes 1. So 2 alpha into 1 plus beta upon alpha. So 1 upon 2 alpha upon 1 plus beta upon alpha. So why we do this? Because we want to put our value of y is equal to 1 upon sigma, 1 upon alpha, and beta upon alpha is equal to sigma. So now we have eta is equal to y upon 2 into 1 plus sigma. Okay, so let's make this y is as a subject of formula y is equal to 2 eta 1 plus sigma. This equation 6 shows relation between y, eta and sigma. Okay, so this shows the relation between y, eta and sigma. Okay, this equation shows the relation between y, k and sigma. Okay, so now just simplify this equation. Y upon 2 eta is equal to 1 plus sigma. So sigma is equal to y upon 2 eta minus 1. So substitute the value of equation 7 in equation 5. We get equation 7 in equation 5. Equation 5 yes, here it is. Y is equal to 3k 1 minus 2 sigma. So y is equal to 3k 1 minus 2 sigma is okay, and we put the value of sigma in this, so it becomes 3k 1 minus 2 sigma is equal to y upon 2 eta minus 1. Okay, so 3k into 1 minus 2 cancel, so y upon eta minus minus plus, so it will be plus 2. So it becomes 3k 1 plus 2 is equal to 3, so 3k to 3 minus y upon eta. So now 3k into 3 is equal to 9k, and 3k into y is equal to 3yk upon eta, and 9k is equal to y plus 3yk upon eta. So now taking y common, we have 1 plus 3k upon eta is equal to 9k. Okay, so it's just simplification of maths. Okay, so eta plus 3k upon eta is equal to 9k. Right. So y eta plus 3k, so it becomes 9k eta. Okay, and y is equal to 9k eta upon eta plus 3k, so it shows the relation between y, k and eta. Okay, y, k and eta. So comparing equation 5 and 6 we get, okay, so what is equation 5? Equation 5 is equal to y is equal to 3k 1 minus 2 sigma, and equation 6 is equal to y is equal to 2 eta 1 plus sigma. So we can compare y and y, so it becomes 3k 1 minus 2 sigma is equal to 2 eta 1 plus sigma. So now taking simplification or doing simplification, 1 minus 2 sigma upon 1 plus sigma is equal to 2 eta upon 3k. So this shows the relation between sigma, eta and k. Okay, so now you might lost some of physics and involved in mathematics, so let's really brush up the concept what we do here. Okay, so we find the relation between sigma, eta and k in this equation. Also we can find this relation between y, k and eta in this equation. Relation between y, eta and sigma shows in equation 6. Okay, and the relation between yk and sigma is shown in equation 5. Okay, and we can find the relation between yk, sigma and eta. Okay, so it's Searle's relation. Thank you.